We will be learning numericals based on density, rank, molar mass, Avogadro number, based on density and atomic radius, based on number of unit cells in a given amount of solid, edge length and radius are related, right? How a formula can be made if there is a data given about certain ions or atoms present in different position of solid state. Then based on radius ratio rule and defects of cation vacancies, defects which are based on metal deficiency. These are all different types of numericals that we are going to study. Coming to the discussion, the right list of formulae. Density is given by the formula for a metallic crystal, rank, that's Z multiplied by atomic mass divided by A cube into Avogadro's number, where D stands for density of metal, Z stands for rank. You are all aware rank is 1 for SCC, rank is 2 for BCC, rank is 4 for FCC and rank is 6 for HCP, where M stands for atomic mass, or you can say for metal molecular mass. For a metal, atomic mass and molecular mass is same because atomicity is 1. NO or Na is Avogadro number, which is 6.022 into 10 to the power 23 mole inverse. A stands for edge length. Usually edge length will be given in picometer, and if you convert this into centimeter, it is 10 to the power minus 10 centimeter. Coming to the next one, what is A cube? A, if it is edge length of the cube, then A cube is a volume of the cube. So remember, A cube is volume of the cube. Now imagine if you are dealing with orthorhombic solids. If you are dealing with orthorhombic solids, then in the place of A cube, the volume will be given by the formula A multiplied by B multiplied by C. All the three parameters multiplied together will give you volume of orthorhombic. So if you are doing the same numerical for orthorhombic, in place of A cube, you can write on A, B and C. But whenever you are doing this numerical, take care, density of metal should be in gram per centimeter cube, molar mass or atomic mass should be in gram per mole, and your A should be in centimeter, so that A cube comes out to be centimeter cube. That was for metallic crystal. If you go ahead with ionic crystal, the formula remains same. Here density D stands for ionic solid, Z stands for rank, but we know in ionic crystal we have only two types of ionic crystal. One is BCC, ionic solid cesium chloride, where rank is 1. Just check BCC ionic solid, rank is 1. BCC metallic solid, rank is 2. Two different things. Metallic solid is different, ionic solid is different. And rank is 4 for FCC ionic solid like NaCl, zinc sulfide, sodium oxide, calcium fluoride. That's what is the parameter. Other things remain same. A cube stands for volume of the cube. NO or Na stands for Avogadro number. That was the first list of the formula for density of metallic crystal and ionic crystal. M stands for ionic solid. Imagine if you are dealing with NaCl, then molecular mass will be 23 plus 35.5. If you are dealing with cesium chloride, that will be mass of cesium plus mass of chlorine, 35.5. Another set of formula that you all people should be aware is for metallic crystal. Remember, when you deal with metallic crystal, all the spheres are of the same size. If all the spheres are of the same size, then those crystals are called as metallic crystal, where if you remember, SCC rank is 1, BCC rank is 2, FCC rank is 4. For SCC, if you remember, right, the spheres were present like this, and from this end to this end, R and R. So that was edge length. So edge length A is equal to 2R. For SCC, there is only one example as a metallic crystal, polonium. If you see BCC, if you remember BCC, then You remember body center there is a sphere, the corners also there are spheres. That means R, R, R and R. 4R will be equal to your body diagonal. Body diagonal is A root 3. Who are BCC? BCC are soft metals. Then coming to the next one, FCC. In FCC, if you take FCC, if you remember, then there is a corner, and there is a face center. So along face center, there will be R, diameter is 2R, another R. So 4R will be face diagonal, and face diagonal is A root 2. Who are FCC? Hard metals, copper, nickel, aluminium and silver. Coming to the next one, for ionic crystal, there are only two ionic crystal in our syllabus. One is NaCl, other is cesium chloride. If you see NaCl, then if the green color spheres are Cl minus, remember this is called as R minus. This is R plus, this is R plus and this is R minus. So from here to here it is edge length, and if you want to know, again if you want to see, this is R minus, this part is R plus, this part is R plus, this part is R minus. That means 2 of R plus and R minus corresponds to edge length. There will be two different kind of spheres in ionic crystal. Unlike metallic crystal, there will be only one kind of a sphere, so only one R. In this case, the formula is A is equal to 2 into R plus and R minus. Rank for NaCl is 4. If you see cesium chloride, rank is 1, and if you go across the body diagonal, then what is this value? R minus. This is R plus, this is R plus, this is R minus. That means 2 into R plus plus R minus is equal to A root 3. This is what is the formula for cesium chloride solid. So for NaCl solid, A is equal to 2 into R plus R minus, and for cesium chloride solid, body diagonal is equal to same 2 into R plus and R minus. Remember, Na plus is present in octahedral void. Because Na plus is present in octahedral void, right, for NaCl like solids, not NaCl, NaCl like solid, radius ratio will lie between 0.414 to 0.732. For NaCl like solid, we should use this formula if there is only one data out of the two. If there is only one data out of the two, this formula should be used. In this case, if you check, there is 3 data. If there is 3 data, out of this, 2 data will be given and 1 will be asked. For cesium chloride, if you remember, cesium occupies cubic void. Therefore, radius ratio lies between 0.732 to 1. This formula should be used if out of this 2 data, R plus and R minus, they give you only 1 data. If they give you only 1 data, then this formula should be used. Right? If they give you 2 data, if you check in this formula, there is 3 terms, A, R plus and R minus. So out of the 3 terms, they will give you 2. When should I use this formula? This formula should be used when there is only 1 data. When should I use this formula? When they give me 2 data. When should I use this formula? When they give me 1 data. When should I use this formula? When they give me 2 data out of the 3. So that was about ionic crystal, how to deal. Now this is mole concept. If you are aware, in mole concept, you can connect molecule with mass by a concept. 1 mole of any substance, I am writing it here. 1 mole of any substance stands for m gram, and m gram stands for any number of particles. From this, you can connect particles and the mass, or particles and the mole. Number of unit cells. Z particles, rank number of particles stands for 1 unit cell. Then n particle stands for how many unit cells? How many unit cells? If you cross multiply number of unit cells which contain n particle is given by the formula n by z. This formula can be by hearted to find number of unit cells. Again, number of unit cells carrying or containing n particles is n by z, when n is number of particles and z is a rank for that unit cell. Number of unit cells in 1 gram of substance. How many unit cells are present in any particles on that ground? N A by Z. Only in the place of n we have put now Na, where Na stands for Avogadro number. We are aware that 1 mole stands for m gram of the substance, and m gram of the substance contain Na particles. Na particles. M gram of the substance contains Na particles. So, 1 gram of the substance contains how much? 1 gram contains how much? So, if you cross multiply, 1 gram contains how many particles? Answer is Na by m particles. Na by m particles. Now, Na by m particle, if this is the number of particles, that's n, then 1 gram of the substance will have how many unit cells? Number of particles divided by z is number of unit cells. Again, check m gram of the substance contains how many particles? Na particles by mole concept. So, 1 gram will contain how many particles? Na by m. So, the number of particles instead of Na you have Na by m. Whatever is the number of particles, now your number of particles is Na by m, divide that by z, that is number of unit cell in 1 gram of the substance. So, you can by heart this formula also, it is Na by m into z. Remember, 1 gram has how many particles? Number of particles present in 1 gram is actually Na by molar mass. So, only in the place of n we have put Na by m and divided by z. Number of unit cells in W gram. If 1 gram of substance have Na divided by m into z, then W gram of the substance will have W multiplied by Na divided by m into z. So, this is what is the number of unit cells. W, that is mass of the substance, multiplied by Na, that is Avogadro number, and this. Remember again, Na by m is for 1 gram. If you take this is number of particles and you divide number of particles by z, that is number of unit cells in 1 gram. But you want in W gram, so multiply by W. You will get the answer of number of unit cell present in W gram of the substance. Then you are aware corner contributes 1/8 to the cube, face center contributes half, body center contributes 1, edge center contributes 1/4. About voids, position of voids. Where is octahedral void present? It is present at body center and edge center. Where is tetrahedral void is present? It is present on body diagonal. If you remember, if this is body diagonal, this is corner and this is body center, then tetrahedral void is present here. So, tetrahedral void is the center of body center and corner in FCC. You are aware FCC is also known as CCP, that was position of voids. What about number of voids? For FCC or HCP, now we are saying HCP also, you know FCC and HCP have same packing ratio of 74%. If number of spheres are n, then octahedral voids are also n and tetrahedral voids are 2n, and total number of voids will be n plus 2n, that will be 3n. Total number of voids. Number of spheres n, number of octahedral voids n, number of tetrahedral voids 2n, total number of voids will be 3n. Coming to the next discussion. This type of discussion is important for ionic structure. If your radius ratio, that is the size of cation to that of the size of anion, or radius of cation to that of radius of anion is less than 0.11155, then your sphere is surrounded by only two other spheres. Coordination number will be 2. If your radius ratio lies between 0.155 to 0.225, then your void will be triangular void and the coordination number will be 3. Boron is present in triangular void surrounded by 3 oxide ions. If it is 0.225 to 0.414, then your cation will be present in tetrahedral void. So, if you remember in zinc sulfide, sulfide makes up FCC and zinc occupies tetrahedral void and its size is between 0.225 to 0.414. If your radius ratio is 0.414 to 0.732, then your cation will be present in octahedral void. Anyone who is present in octahedral void will have coordination number of 6. Here in this case, if you remember, Cl minus makes up FCC and Na plus occupies octahedral void. Na plus occupies octahedral void with coordination number of 6. If your radius ratio lies between 0.732 to 1, better to remember 1, then coordination number is 8. Example, cesium chloride, where chloride was making SCC and cesium was present in cubic void. So, that's again discussion in NaCl, Cl minus occupy FCC. What do you mean by FCC? 8 corners and 6 face centers. And Na plus occupies octahedral void. What do you mean by octahedral void? One body center and 12 edge centers. Remember that. If you want to know exact size of triangular void, it is 0.155 multiplied by R. What does that capital R stands for? Capital R stands for radius of the spheres which make triangular void. Again, size of tetrahedral void. If you want to know exact size of tetrahedral void, it is 0.225 of capital R. What is that capital R? It is the radius of the spheres which make up the tetrahedral void. Exact size of octahedral void is 0.414 multiplied by R, where capital R again stands for radius of the sphere, and exact size of cubic void is 0.732 multiplied by R. All such numbers have to be remembered. All these numbers have to be remembered, even the exact size and the range. Algebraic shortcuts that you should know. If edge length is given as 400 picometer, remember that's 400 multiplied by 10 to the power minus 12 meter, picos value. Convert this into centimeter. If you convert this into centimeter, 10 to the power 2 centimeter, that is nothing but 400 multiplied by 10 to the power minus 10 centimeter. Conclusion, whatever is this, just multiply by 10 to the power minus 10, you will get centimeter. Again, if you rewrite, can I say it is 4 into 10 to the power minus 8 centimeter? From this, we realize if your edge length is 3-digit number in picometer, convert this into 1-digit number with decimal place, multiply by 10 to the power minus 8, that is your edge length in centimeter. So, next time when you have edge length as 320 picometer, we can directly write on 3.2 into 10 to the power minus 8 centimeter. Similarly, if edge length is given as 2 angstrom, then same logic, write down one digit and write on 10 to the power minus 8 centimeter. That means more often in the chapter of solid state, edge length will be one digit with some decimal places multiplied by 10 to the power minus 8 centimeter. So, whether it is an angstrom or whether it is a picometer, you can conveniently write down. Next thing, you should be aware, density of heavy metals will be usually 8 to 17 gram per centimeter cube. This is for heavy metal. Density of light metal, very light metal, can be like this as 0.7 to 4 gram per centimeter cube. Even ionic solids have density in this range. Whenever you want to use Avogadro number in the chapter of solid state, you can very well write down 6 into 10 to the power 23 like this. And you want to do cube root, how to do a cube root? Remember, 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. So, somebody asks you cube root of 1, you know it's 1 only, cube root of 8 is 2. Now, imagine somebody asks what is cube root of 6. Now, we don't know the value, but at least we know it will be between 1 to 2. At least that much guess you can do. Cube root of 27 is 3. But now somebody asks what is a cube root of 20? We know 20 lies between 8 and 27. 8 cube root is 2, 27 cube root is 3. So, 20 cube root will be between 2 to 3, but closer to 3. Similarly, somebody asks what is cube root of 100? Think what is cube root of 100? We are aware cube root of 125 is 5. Cube root of 64 is 4. 100 lies between 64 and 125. Therefore, your answer will be between 4 to 5, but closer to 4. So, these were all the algebraic shortcuts that you should be aware while dealing with numericals of solid state. So, we come to the numericals of cation vacancies. When one strontium ion enters into NaCl crystal, we are aware 2 Na plus ions. 2 Na plus ions are removed. Why? Because one strontium ion has a charge of 2 plus, which is equivalent to 2 sodium ions, of which one sodium ion's position is taken by strontium, one sodium ion which is lost, that position is taken by strontium, and the other place remains vacant. That means there is one cation vacancy. So, correlation, one strontium ion will cause one cation vacancy and will remove 2 sodium ions. Using this relation, we will be solving numericals. Imagine if there is one aluminium ion entering into sodium chloride crystal, then it will remove 3 sodium ions from the system, of which one sodium ion's position aluminium will take and will create 2 cation vacancy. So, one aluminium ion will create 2 cation vacancies. But why the word imagine? Because this is a hypothetical example. The real examples are with only divalent ion, not with trivalent ions. So, this is imagination. So, one aluminium ions will remove 3 sodium ions and will create 2 cation vacancy. Using this, we will be solving various numericals. Numericals based on metal deficiency defect, in which metal is lesser in number than an ion. In this case, let the number of oxide ions be 100. If oxide ion is 100, then we know this type of deficiency defect is there because system contains both ferrous as well as ferric ions. So, if oxygen is 100 or oxide ions are 100, Fe is 93. If Fe is 93, Let ferrous be X. But why ferrous X? Because they are asking for ferrous. Then how much will be ferric? 93 minus X, because total Fe ions are 93. Total positive charge and total negative charge is equal to 0 for any system to maintain neutrality. Positive charge is due to ferrous and ferric ions, while negative charge is due to oxide ions, and total is 0. So X ferrous has a charge of 2. Remember that. Ferric has a charge of 3. Number of ferric ions are 93 minus X. So total charge on ferric ions is 93 minus X multiplied by 3. 100 oxide ions multiplied by minus 2. If you solve, you will get the value of X as 79. So number of ferrous ions will be 79 divided by total 93. So that's how you get percentage, and the answer will be definitely common sense more than 79, and that will be 85 percentage. This is what is the logic of solving metal deficiency defect. In metal deficiency defect, consider the anions by some number, more commonly 100. Natural Fe will be 93. Whatever they are asking, put it as X. Remaining will be 93 minus X. And by using charge neutrality equation, you will be able to get the unknown. That is the logic of solving numericals based on metal deficiency defect. So first type of the numerical, which are based on density. If you see this numericals which are based on density, then how many variables are available in this? One is density, other is rank, molar mass, and A. These are variables because Na value we already know as 6.022 into 10 to the power 23. We are aware. So there are 4 variables. Out of these 4 variables, 3 variables will be given and 1 variable will be asked. More often, that variable which will be asked is either density or edge length. So these are the commonly which are asked, either density or edge length. If you know, Z value is 1 for SCC, 2 for BCC, 4 for FCC, 6 for HCB. Remember that. And whatever is a value given in picometer, if you convert into centimeter, it's 10 to the power minus 10. Density for ionic crystal, what is important? For BCC ionic solid, rank is 1. For BCC metallic solid, rank is 2. Remember that. For FCC ionic solid, 4. For ionic crystal, there are only 2 types of ionic crystal. One is BCC ionic crystal, other is FCC ionic crystal. We come to the first numerical, which is based on density, rank, molar mass, and so lithium crystallizes in body-centered cubic structure. You are aware formula is density is equal to Z multiplied by M divided by A cube into Na. And we are also aware for BCC rank is 2. So rank value is 2 for BCC. So we are aware of Z. Z value is known. Then they are asking determine the density of lithium. Lithium's atomic mass also will be given in the exam. Edge length is available. Right, atomic mass of lithium also will be given. Atomic mass, that is molar mass of the lithium, also will be given. So Na is already known. What is the value of Na? Edge length. Not Na. Na is Avogadro number 6.02 to 10 to the power 23. So what is the formula that we use? The formula that we use is D is equal to Z multiplied by M divided by A cube into Na. This is what is the formula that we are aware, where Z or Z stands for rank and M stands for atomic mass and A stands for edge length. We are aware of these factors. And molar mass of lithium, which will be given in the exam, is 7 U, or more often it is written as 7 gram per mole. What is the value of A? A value is 350 picometer. 350 picometer, if you know by the algebraic shortcut, 3.5 into 10 to the power minus 8 centimeter. Take care that the edge length should be in centimeter and this should be in gram. Then only density will be coming in gram per centimeter cube. So, value of Z 7, not Z, right, value of Z is 2, atomic mass is 7, A value is 3.5 into 10 to the power minus 8, the whole cube multiplied by Avogadro number 6.022 into 10 to the power 23. So, if you write down, it is 2 multiplied by 7, 3.5 the whole cube multiplied by 6.022, this is 10 to the power minus 24, 10 to the power 23, that is 10 to the power minus 1. So, if you write down further, density will be 2 multiplied by 7 divided by 3.5 the whole cube multiplied by 6.022 into 10 to the power 1. This is what we get. Now, for board examination, you have to do it by as much as log as much as possible. For MCQ, you can do it by approximation. How to do it by log? So, actually you can cancel 3.5 and 7 ka factor, but let it remain anyway. Finally, we have to do log only. So, you will take log of numerator. Log of numerator will be log of 2 plus log of 7, like this. What we do is we calculate everything else except the 10. If you want 10 also to be included, then make it 70. What is the characteristic of 2? 0. And what is characteristic of 70? 1. And then you are supposed to see the logbook. From the logbook, remaining values can be calculated. This will give you log of numerator. What next? Similarly, calculate log of denominator. That will be 3 times log of 3.5. You all are aware whatever is cube is actually a multiplication. And you will get a number by seeing a logbook. Characteristic of 3.5 is 0. Remaining part you will see it from logbook. And log of 6.022 characteristic is 0 and you will get the remaining number from the logbook. That is log of denominator. Then log of numerator minus log of denominator will give you a number, and you take anti-log of that number will give you answer. Are you aware how you are supposed to do the log calculation? I am not wasting time calculating individual log values, right? This can be done as a separate session. This is how you are supposed to do the log calculation. In case of MCQ approximation, how we can do? MCQ approximation is density is 2 multiplied by 7 multiplied by 10. We are doing MCQ approximation, that is 3.5 multiplied by 3.5 multiplied by 3.5 multiplied by 6. So, this factor gets cancelled 2. So, you are left with 4 at this place. This is 3.5, 3.5, 3.5, 3.5, or this is 40. This is 7 by 2 into 7 by 2 into 6. So, we can simplify these numbers to a certain extent, not much. So, you will be left with what? It will be left with 80 upon 7 into 7. 7 into 7 is 49. So, 49 for as good as purpose is 50, because 2 I have taken it on the top. So, it is 80. 80 divided by 7 multiplied by 7, 49. For 49 you can take it as 50 multiplied by 3, and then you simplify as much as possible. You will be able to get the numbers. Are you understanding it how you are supposed to do? That was MCQ approximation. In the board exam, log calculations are compulsory. In our MCQ examination, you have to do by approximation. So, that was the first numerical of density. Coming to the next numerical of density related only. In this case, density is already given. You are aware of the formula, density is equal to Z or Z multiplied by M divided by M cube into NA. How many variables are there? D, Z, M and A. Out of this, how many should be given? 3. Just check. They have given M, they have given density, and they have given body centered cubic system. That means Z ka value is given. That means they have given density, they have given Z, they have given you M. So you can easily calculate edge length. So, alright, it is like this. You are aware for BCC, the rank value is 2. So, formula density Z is equal to M multiplied by Z multiplied by M upon A cube into NA. So, we rearrange for A cube. This will be what is the formula which is applicable. And then we substitute the value of Z, that's 2, value of M is 50, density is 6.8, and Avogadro number is 6 into 10 to the power 23. This is what you will get. So, A cube will be 100 multiplied by 10 to the power minus 23 divided by 6.8 into 6. Like this you will have suggestions. Suggestion is make this as one more 0, 6.8 into 6 and make this as 10 to the power minus 24. Put one more number here and decrease the number here. Okay, like this we have done. And A value will be cube root of this. That means cube root of 10 to the power minus 24 is 10 to the power minus 8 centimeter, and you will get a number. So, 1000 divided by 6.8 multiplied by 6, that is what we are having. So, right, approximation will be 1000 upon 7 or into 6. This is what is an approximation. 7 multiplied by 6 is 42, that's 40 for all practical purpose. So, 1000 upon 40, if you take 1000 upon 40, you will be having 25. So, you are taking a cube root of 25. Cube root of 25, we know cube root of 27 is 3. So, cube root of 25 will be close to 3 but less than 3. So, 2.9 into 10 to the power minus 8 centimeter. Whatever is a number, this number make it 3-digit number multiply by 100, that is picometer. So, it is 290 picometer. This is what is the next numerical. Always look out for 3 variables. Once you have seen 3 variables, then go ahead and do it. And one more algebraic shortcut that we have learned, always keep this as 10 to the power minus 24. So, your cube root will always give you 10 to the power minus 8 centimeter directly. Take care, this should be in gram per centimeter cube. This by default U means gram per mole only, remember. That means it is gram only. So, your answer will be definitely coming in centimeter. Any number, 1-digit number converted in centimeter of this part, make it as 3-digit number, you will get picometer. Question number 3. In this case, again look out for 3 variables. FCC, that means Z ka value is 4. Edge length is given as this much. And density is already given. And they are asking you to calculate atomic mass. When such a numerical comes in the exam and you are already aware of atomic mass of silver, in MCQ exam don't solve, directly write the answer. But in board exam you are supposed to solve. If it is an MCQ, do not solve such questions which are already physical constants world over known. So, again formula is this, and we have got 3 variables. So, density is 10.5, Z ka value is 4, molar mass you don't know, A ka value is 4 into 10 to the power minus 8 the whole cube, and N value is 6 into 10 to the power minus 23. So, M will be what? 10.5 into 4 cube into 6 into 10 to the power minus 1. If you solve 10 to the power minus 24, 10 to the power 23, 10 to the power minus 1 divided by 4, and then you solve, you will be able to get the answer, required answer for density. Are you understanding it? How you will get the required answer for density? Another one, in this case density of chromium is given and it is given in gram per centimeter cube. Then edge length is given as 289 and they are asking you to determine the type of unit cell. If they are asking you to determine the type of unit cell, if Z ka value comes out to be 1, it is SCC. If Z ka value comes out to be 2, it is BCC. If Z ka value comes out to be 4, it is FCC. Again use that formula. Again use a formula. Density is Z multiplied by M divided by A cube into Na. Substitute the required value 7.29. For approximation purpose, this can be taken as 7.2 also, because 7.2 is cancelable. Z ka value we have to calculate, because that's what is the question all about. Molar mass is 52 and A value is 289, that is 2.89 into 10 to the power minus 8 the whole cube multiplied by Avogadro number, that is 6 into 10 to the power 23. So, you will get the value of Z or Z. So, from that Z value you will be able to know what type of a unit cell we are dealing with. Coming to the next type of a numerical here, another one. Density of mercury is 13.6. D is given, and they are saying each atom of mercury occupies a cube of edge length equal to diameter of mercury. So, they are saying edge length is a diameter of mercury, that is A is equal to 2R. This formula is applicable, but this formula is applicable for SCC, and we know the rank is 2, not 2, 1. So, for SCC rank is 1. So, in this case they have not given rank directly, but they have given in terms of some data that edge length is 2 times the mercury atom. So, from that we realize SCC is present. So, Z value is 1. So, they have given density, they have given Z, they have given atomic mass. So, they have given you 3 values. From 3 values you will be able to get the answer. Understood this how the numerical can be done? If you want, I will just write down that formula which is applicable. For SCC rank is 1, remember, density is Z multiplied by M upon A cube into Na. Density is 13.6, Z value is 1, which was indirectly given. The atomic mass is 201. A cube value you have to calculate. Avogadro number is 6 into 10 to the power 23. From that you will get the value of A, and from A you will get the value of R, which is A by 2, because A is equal to 2R. This is how you will get radius of mercury atom. So, these were all different types of numericals associated with density. More numericals associated with density, but now there is a change. You are now dealing with metallic solid. You are dealing with what? Ionic solid. So, you should know you are dealing with cesium chloride, BCC, but you know it is ionic solid. So, rank is 1. Again, if you remember, there are only 2 type of ionic solid, NaCl and cesium chloride. Cesium chloride rank is 1, it is BCC, remember that. And they are asking us to calculate density. Are you understanding it? So, how we are dealing with? So, density is given by the formula Z multiplied by M divided by A cube into Na. Density, they are asking us to calculate. Z value is 1 because it is an ionic solid, BCC, ionic solid rank is 1. Molar mass of cesium chloride, you have to add cesium and chloride both. If you add it, it will be 168.5. You know that if you add this, it will be U, 168.5 U, and U is nothing but 168.5 gram per mole. A value is 4.12 into 10 to the power minus 8 the whole cube. 412 is nothing but 4.12 into 10 to the power minus 8 centimeter. Avogadro number is 6 into 10 to the power 23. If you do this algebraic calculation in the best possible manner, you will get density. What is worth noting is density is quite low, right? Quite low density is applicable for alkali metals like lithium, sodium, and for ionic solids. Ionic solids also have low density, while heavy metals have density in the range of 7 gram per centimeter cube or 10 gram per centimeter cube. Still heavy like mercury, 13.6 gram per centimeter cube. There can be more heavy also, 15 gram per centimeter cube. This is for all heavy metals. While light metals like alkali metals, ionic solids have density very low. Alkali metals can have density like lithium can have density 0.6 gram per centimeter cube, or sodium can have density 0.8 gram per centimeter cube. These are all different values related to density. Now, here they are asking what is the distance between Na plus and Cl minus in NaCl crystal. If they are asking you distance between Na plus and Cl minus, that means this to this, they are asking this much distance. If you know this is nothing but R plus and this is R minus. If you want me to show it here, this is R plus and this is R minus. So they are asking us to calculate R plus and R minus value. Distance between two oppositely charged ions. We are aware this is what is the formula, and if you check R plus plus R minus is given by this relation, that means it is A by 2 if you see it from this formula. So you are aware that 2 into R plus plus R minus is equal to A. Therefore, R plus plus R minus is equal to A by 2. That means in this numerical also you are supposed to calculate A. Once you know the value of A, then A by 2 will give you the required answers. Again, observe density is quite low. That's speciality for all ionic solids. Formula is density is equal to Z multiplied by M upon A cube into Na. Density is 2.165. Z value for NaCl you already are aware. It is 4. There are only two type of ionic solids. NaCl like solids and cesium chloride like solids. And molar mass is 58.5. And A is asked, and Na you are already aware 6 into 10 to the power 23. From this you will get the value of A, and from A you will get R plus R minus. That's the distance between Na plus and Cl minus will be given by A by 2, and from this you will get the answer. So this is how you are supposed to solve this type of a numerical. Observation is density is quite low, and when they ask distance between cation and anion, remember we have a formula available for a distance between cation and anion. Density and atomic radius. We are aware that for FCC Z value is 4. Remember that. What they are asking is, they are asking you radius. How you are supposed to deal with it? We are aware the formula is D is equal to Z multiplied by M upon A cube into Na. From this formula, we will get the value of A. And from the value of A, you will get the value of R. How to get from A value of R? By the formula A root 2 is equal to 4R. So what is the formula that we are going to use? A root 2 is equal to 4R. So once you get the value of A, you can get the value of R. So the formula that we are going to use is density is equal to Z multiplied by M divided by A cube into Na. So in this, we substitute the value of density 22.4. That's highly dense. Iridium is the most dense metal of the periodic table. Z value is 4 and molar mass is 192.2. A cube value is not known. Na is 6 into 10 to the power 23. If you are dealing in board exam, then 6.022 will be used for board calculations. Otherwise, for MCQ, 6 into 10 to the power 23. From this, you will get the value of A, which will be in picometer. Then A root 2 will be equal to 4R, and from this you will put the value of A, you will put the value of root 2 as 1.414 will be equal to 4 into R. From this you will get the value of R. So that's the only extra part. So when you are dealing with numericals of density and atomic radius, your methodology is from density formula get the value of A, and from the value of A get the value of R. That is what is a methodology. You should know iridium belongs to metallic solid. There are two types of solid, metallic solid and ionic solid, and we have used metallic solid relation. Before we go to the next type of a numerical, you all are aware mole concept says any atoms or molecules corresponds to 1 mole, which corresponds to molar mass. Number of unit cells. We have learned this right in the numerical approach. Rank, Z particles make up 1 unit cell. So N particles will make up how many unit cells? So it is N by Z. So remember, in N particles, number of unit cells are N by Z. So, if you deal with Na particles, number of unit cells will be Na by Z. Now, remember m gram of the substance corresponds to Na particles, m gram of the substance corresponds to Na particles. So, 1 gram of substance will correspond to how many particles? It is Na by m. So, what are the number of particles? So, number of particles in 1 gram of substance, number of particles in 1 gram of substance is Na by m. So, in number of particles is Na by m. So, instead of n particles, now how many particles you have got? Na by m. So, your unit cell is, you just simply divide by number of particles by the rank, you will get that many number of unit cells. This is for 1 gram of substance. So, again 1 gram of substance have Na divided by m into Z. Remember, Na is Avogadro number. Then W gram of substance will have how much? Cross multiply, you will have W multiplied by Na divided by m into Z. This formula will be used for calculation of number of unit cells. Coming to numericals based on unit cells. Aluminium has atomic mass of this much, that's m. It is a F-centered cubic, so Z ka value is 4. They are calculating number of aluminium atoms in 10 gram. How to get number of aluminium atoms in 10 gram? We know by 1 mole corresponds to what? 27 gram, and 27 gram corresponds to 6.022 into 10 to the power 23 atoms. For aluminium, particles are atoms. So, 10 gram will have how many particles? 6.022 into 10 to the power 23 multiplied by 10 divided by 27. So, that many number of atoms are there. You want to calculate number of unit cells in this? Yes. How to calculate number of unit cell? Number of unit cell is given by the formula n by Z. What is the value of n? 6.022 10 to the power 23 multiplied by 10 divided by 27. What is the value of Z? 4, and you will accordingly get the answer of number of unit cells. Is there any other alternate method? Yes, another alternate method to calculate unit cell is this formula. So, number of unit cells will be mass 10, Avogadro number 6.02 to 10 to the power 23, molar mass 27 multiplied by 4. If you recalculate this value, you will also get the same answer. If you check 10, right, I can write down in front also, 10 multiplied by 6.02 to 10 to the power 23, and 27 and 4 are both are in numerator, right, denominator. So, 27 multiplied by 4. Is it not the answer same? So, you do it by mole concept, you will get the still the answer, or you can directly do by formula. Directly doing by formula is MCQ method. So, 1 mole 27 gram Avogadro number of particles. So, 10 gram has how many particles? So, number of particles in 10 gram is this. And we know number of unit cells is given by the formula n divided by Z. So, that is the value of n, and this is the value of Z, and this is how you get the answer. So, this is how you are supposed to do the numericals of finding number of unit cells. So, the next question, aluminium crystallizes in cubic close packed. Cubic close packed, CCP means Z ka value is 4. You know CCP is another name for FCC. And we have given metallic radius, that is the R, and they are asking you what is the length of the side of the unit cell and how many unit cells are there. How you are supposed to deal? How you are supposed to deal? We are knowing for FCC 4R is equal to A root 2. You remember 4R is equal to phase diagonal. So, from there A, if you solve, it is 2 root 2R. Put the value of 2, put the value of root 2, put the value of R, you will get by solving 353.5 picometer, that is edge length. That is the first answer. Now, if you take 1 unit cell, what is its volume? Because it is cube, its volume will be A cube. So, 1 unit cell has A cube volume. A, if you convert this into a centimeter, you know how to convert into a centimeter. Convert this into 1 digit number multiplied by 10 to the power minus 8 cube centimeter cube. This stands for 1 unit cell. So, 1 unit cell corresponds to 3.535 into 10 to the power minus 8 centimeter cube power. So, 1 centimeter cube has how many unit cells? Why like this? Because we are asking for 1 centimeter cube. So, for 1 centimeter cube, how many unit cells are there? Cross multiply, you will get the answer as 2.26 into 10 to the power 22 unit cells. That is what we get, number of unit cells of the numerical based on edge length and atomic radius. If you when you do this type of a numerical, be careful which type of a numerical are you dealing with, ionic or metallic. If they use the word element, that means it is metallic solid. If they say some another word, oppositely charged ions, that means they are saying ionic solid. They have given you the radius and they have given you FCC, and you are aware there is a formula in terms of FCC, that is A root 2 is equal to 4R, of which they have already given you the value of R radius 127.6, and from this you will get the value of A, which will be in picometer. If you do this calculation, you will get the value as 360.8 picometer. One of the easiest numerical, because we know all this numerical there are only two variables, one is A and other is R. Out of the two variable, one will be given and other will be asked, or other will be given and the next one will be asked. Only thing is, you should be careful whether you are dealing with ionic solid or you are dealing with metallic solid. If they use the word element, then definitely metallic solid. Coming to the next one, question number 2. Again, before starting, check what they are asking. Sodium, that means metallic solid. BCC, rank is 2. They are asking you distance between two nearest sodium. If you take two nearest sodium means sodium which touch each other. If you find out distance between two nearest sodium atom, that means you are trying to find out 2R. Remember, we are asking between two nearest sodium atom, and that is 2R. And for BCC, the formula is 4R is equal to A root 3, and what they are asking, 2R. So, from this, what is 2R? A root 3 by 2. A value is given? Yes. No, not A value is given. They have given you distance between two sodium atoms is 368. That means 2R value is given, 268. And they are asking you A value, 1.732 divided by 2. And if you solve, you will get the value of A in terms of picometer, because this is in picometer. Remember, nearest distance in metallic solid is 2R. Nearest distance in ionic solid, you know ionic solids have cation and anion. Nearest distance between ionic solid is R plus and R minus. So, for metallic solid, nearest distance is 2R. For ionic solid, nearest distance is R plus and R minus. Coming to the next, this numerical had been asked in NEET examination. You are saying AB. Now, as soon as they say the word AB, that means it is ionic solid. It is not a metallic solid. It is BCC. Any ionic solid that you know is BCC format? Yes. Cesium chloride. So, remember it's cesium chloride like. And they are asking what is the distance between two oppositely charged ions. Distance between two oppositely charged ions, that means they are asking R plus R minus value. Now, it's cesium chloride like solid and they are asking you R plus and R minus value. And you are knowing R plus R minus value is nothing but A root 3 by 2. This is how cesium chloride like solid is there, and if you are aware, a long body diagonal, you will find this is R minus, this is R minus, this is R plus, this is R plus. Therefore, 2R plus R minus is body diagonal. A root 3, R plus R minus is equal to A root 3. Value of A is given 387 picometer. The root 3 value is 1.73 divided by 2. You will get the answer in picometer. Very easy numerical. But careful. AB, that means you don't have one set of atoms. You have two different set of atoms. Two different set of atoms means ionic solid. And you should know it's a BCC ionic solid means like cesium chloride. If it is like cesium chloride, it will have formula of cesium chloride. This is how the numerical of NEET 2010 MCQ should be solved. Another type of a numerical which is of formula making. Zinc sulfide crystallizes with zinc ions occupying half of the tetrahedral holes in closed packed array of sulfide ions. So, remember closed packed array of sulfide ions. That means sulfide ions makes up CCP. So, you can consider number of sulfide ions as 4. Remember it is CCP means FCC, and remember that is what is making up spheres. So, your entire crystal lattice is made up of sulfide, which is 4. You are aware if number of spheres, in this case sulfide is a sphere, is n, then octahedral voids are n and tetrahedral voids are 2n. So, what is the number of tetrahedral void? Number of tetrahedral void is 2. If this is n, 2n means 2 into 4, 8 will be tetrahedral voids. If 8 are tetrahedral voids, then how many zinc ions are present? Number of zinc ions are half of the tetrahedral voids. Half of tetrahedral voids, that is 8, that is 4. So, what we realize, number of zinc ions are 4, number of sulfide ions are also 4. So, if you simplify, the ratio will be 1:1. So, 1 zinc and 1 sulfide. So, your formula is zinc sulfide. That is how the formula of zinc sulfide is. So, now when you imagine zinc sulfide, remember zinc sulfide is a solid. In that solid, right, the entire lattice is made up of sulfide ions, entire lattice. What do you mean by entire lattice? It makes up 8 corners and 6 face centers are made up of sulfide ions. 8 corners and 6 face centers are made up of sulfide ions. That means number of sulfide ions are 4. You know 8 corners and 6 face center corresponds to 4. Right, that is the value of n. So, number of tetrahedral voids are 2n, that will be 8. Zinc occupies half of the tetrahedral holes, half. So, it is 4. So, zinc ions in a unit cell are 4, sulfide ions in unit cell are 4. If you simplify, 1:1. Therefore, the formula of zinc sulfide is ZnS. This is how easy numericals are there of formula making. Another numerical of formula making. Ferric oxide is crystallized in hexagonal closed packed array of oxide ions. You should know HCP is oxide ions. So, number of oxide ions are how many? Number of oxide ions are 6 because they are making HCP, and remember that is the value of n. You are aware of that formula is if number of spheres are n, how many octahedral holes will be present? Is n only, so it will be 6. If number of octahedral holes are 6, then number of ferric ions are how many? Number of ferric ions are 2 out of 3 tetrahedral holes. 2 out of 3 octahedral holes. Octahedral holes means 6. That means 4. So, number of ferric ions are 4. number of oxide ions are 6. If you simplify 2 and 3, so formula of ferric oxide will be Fe2O3. So next time when you visualize ferric oxide, remember oxide ions makes up HCP. You can simplify it as CCP also because packing efficiency is same, and ferric ions occupy 2/3 octahedral voids. Therefore, the formula is Fe2O3. That was another numerical of formula making. Third numerical of formula making. C and D form FCC crystalline structure where C is present at the corners and D is present as the face of the cube. So, if C is present at the corner, how many corners are present? Corners are 8 and each has a contribution of 1/8. So, actual number of C will be how much? Is 1. D is present at face of the cube. So, it is face center. How many face centers are there in a cube? 6. Every face center contributes half. So, number of D will be 3. So, number of C 1, D 3. Therefore, formula will be CD3. That will be the formula. So, CD3 is a formula. So, C makes up corner. So, it is 8 in number. Each has a contribution of 1/8. Number is 8, contribution is 1/8. If you multiply, you get actual contribution, that is 1. Number of face centers are 6, contribution is half. If you multiply these two numbers, you will get actual number of D. So, actual number of D is 3 and actual number of C is 1. Therefore, formula is CD3. We go to the next numerical. The next numerical is PQR crystallizes in cubic structure with P present at the corner, Q present at body center and R present at H center. So, you can make a tabular column and write down P makes up corner. Corner means it is 8. Each contribution 1/8. If you multiply this two, you will get actual contribution 1. Q is present at body center 1. Each body center contributes 1. If you multiply this two number, you will get actual contribution. R is present at the H center, so it is 12. If you multiply by 1/4, the actual number of R is 3. So, P is 1, Q is 1, R is 3. Therefore, formula is PQR3. A numerical of solid state. If you see AB, then you know it is ionic solid. Okay, or you can say it is alloy. Then A occupies CCB arrangement, which is also known as FCC. B occupies all the octahedral void. When you say it is octahedral sites, that means remember it occupies edge center and body center. Remember that it occupies all the edge center and body center. But they have given something special. If all the face centered atoms along one of the axes are removed, that means they have removed the face centered atoms, then what will be the resultant stoichiometry? Now, if you check, then we know that Cl minus makes up FCC in NaCl like solid. If you remember, in NaCl like solid, Cl minus makes up FCC and Na plus occupies octahedral void. Octahedral void means edge center and body center. Are you able to see? This is edge center and this is body center. Edge center, edge center, edge center. While somebody says FCC, means you know it occupies corner and face center. Now, what they have given? Something more they have given. They have said that there is an axis passing. It has to pass through face centered atoms only. So, it is passing through face centered atom. Are you understanding it? These are the face centered atoms which I am shading it out. Are you able to see? Shading it out. These are the face centered atoms. It is passing through this. When it is passing through this, it is passing through two face centers and body center also. Now what next? Only face centered atoms are removed. That means body center is not removed. This is there, this is removed, and this is removed. So what you can understand? In NaCl, now there are two methods of doing it. We are doing it by method 1. In NaCl, you remember Cl minus is 4 in number, rank 4, and Na plus is also 4 in number. Now who is removed? They have removed two face centers, but they have not removed body centers. How you came to know? It is given only face center atoms are removed. Two face centers are removed. Now two face centers, each having a contribution of half. That means actually one has got removed. That means Cl minus has got removed by 1, and therefore the net Cl minus is 3. Now you should check, right, who is your Cl minus in this case? CCB arrangement or FCC arrangement is A, while B is like Na plus, which is in octahedral void. So this is B. So A is 3 and B is 4. Therefore your answer is A3B4. This is one method of doing it. I repeat what it is. We are imagining AB is like NaCl, where A is like Cl minus and B is like Na plus. But why so? Because A atom occupies FCC and Cl minus also is FCC, and B atoms are octahedral voids. Are you understanding it? Then there is an axis, and along the axis only face center atoms are removed. That means this atom of Cl minus and this atom of Cl minus is removed. That means two Cl minus are removed. Each have contribution of half as a face center. That means one Cl minus is removed. So out of 4, one Cl minus is removed. So how many Cl minus is left? 3. But you should know Cl minus is nothing but A for us, and Na plus is like B, and there is no body centered removed. So it remains intact. Therefore A is 3 and B is 4. There is another method also of solving this, method number 2. What is that method? A is CCP. When you say CCP, that means it is at corner and it is at face center. It is at corner and it is at face center. Remember, B is octahedral void. When you are saying it is octahedral void, that means it is edge center and body center. How many corners are present? 8. How many face centers are present? 6, but out of that 2 is removed. How many edge centers are present? 12. How many body centers are present? 1. That's the number. Contribution. How much is a contribution? Contribution is 1/8, contribution is half, contribution is 1/4, contribution is 1. So this is 1, this is 2. If you calculate 12 multiplied by 1 by 4 is 3, 1 multiplied by 1 is 1. So actual number of A is how many? This is A. A is a number 3 and B is a number 4. So A3B4. That is another method of solving the same numerical. This numerical has been already asked in one of the JEE paper. Solid state numericals which are based on radius ratio. When you say radius ratio, you should know that we are talking about ionic structures. If your radius ratio, what do you mean by radius ratio? R plus upon R minus. That is, size of cation upon size of anion lies between 0.155 to 0.225. That means your cation will occupy a triangular void. If it occupies triangular void, then it will have coordination number of 3. Example is B2O3, where boron occupies triangular void. If your radius ratio is 0.225 to 0.414, then your cation will occupy a tetrahedral void. Tetrahedral void means coordination number will be 4. Example is ZnS, where sulfide makes up CCP or FCC, that means 8 corners, 6 face centers, and zinc occupies 50% tetrahedral voids that we have learned in the theory part. If your radius ratio lies between 0.414 to 0.732, then it occupies octahedral void. Your cation occupies octahedral void. Naturally, will have coordination number of 6. Example in ACL. In NaCl, Cl minus makes up FCC. That means 8 corners, 6 face centers. And Na plus occupies 100% octahedral void. Why Na plus occupies octahedral void? The answer is radius ratio. Because the radius ratio of Na plus to that of Cl minus is 0.53. It lies between these two values. Therefore, Na plus occupies octahedral void. If your radius ratio lies between 0.732 to 1, then your cation will occupy body center, or you can say cubic void. Example, cesium chloride, where chloride makes up SCC. When somebody says SCC, 8 corners, and cesium occupies body center, or you can say cubic void. Now, if you want to know exact size of tetrahedral void, exact size of tetrahedral void is 0.225 of R, where capital R stands for the spheres which make up the tetrahedral void. Exact size of octahedral void is 0.414 R, while exact size of cubic void is 0.732 R. That's the exact size of cubic void. Now, NaCl has been described. Again, if you check in NaCl, chloride ions occupy FCC, 8 corners, 6 face centers. And Na plus occupies octahedral void, means 1 body center and 12 edge centers. That is what you should know when you learn about radius ratio. How are numericals constructed? Right, they will give you size of cation, size of anion. When you get size of cation, size of anion, the first thing that you do is you take the radius ratio of cation to anion. So 1.67 divided by 1.84. So value is 0.91. If you know the data, if your value lies between 0.732 to 1, what does that mean? Your cation will be present in dash void, cubic void. You say cubic void or you say body center, it means same. That means it will be present in this. And what will be right coordination number of cubic void? Coordination number of cubic void will be 8. How will be the structure? How will be the structure? The structure will be like this, where chloride ions will be present at all the 8 corners and cesium ion will be present in the cubic void. And coordination number of cesium will be 8, because cesium will be surrounded by 8 chloride ions. So what is the type of unit cell? If you want, you can say cubic, or you can better write on the answer as BCC, because Cl minus is SCC and cesium is cubic void. If you consider cesium chloride overall, it is BCC, because 8 corners are occupied and even 1 body center is also present. So BCC. Coordination number is 8. That's what's the answer for question number 1. Question number 2. Again, when you see that question, you are able to see size of cation, size of anion is given. Once the size of cation, size of anion is given, what's the first task that you do? You find out radius ratio. So 0.9858 upon 1.86. If you do a precise calculation, the value is 0.53. And you know 0.53 lies between 0.414 to 0.732. That means the cation will occupy dash void, will occupy octahedral void. And you know octahedral void, that means its coordination number will be what? 6. So if you want to visualize how it will be a cubic system, FCC by default we consider, where anion will occupy FCC, anion, this is anion, will occupy FCC and FCC means it will occupy face center also, and cation will occupy what? Edge center. That's octahedral void, edge center, and will occupy even the body center. That is what is the structure. If somebody says, if somebody is present in octahedral void, you should know tetrahedral void and octahedral void are speciality of FCC, HCP. By default in this chapter, if no information, we are taking cube. So we have considered everything as FCC. Again, I am saying if there is a data which tells you that a cation occupies tetrahedral void or octahedral void, remember anions will make up FCC. We go to next type of cation vacancy. Imagine in crystallization of NaCl, if one strontium ion enters, then it will displace two sodium ions. Two sodium ions will be removed to maintain charge neutrality. One sodium ion's position will be taken by strontium, and other sodium's position will remain vacant, creating something called as cation vacancy. So one strontium ion will produce one cation vacancy and will displace two sodium ions. That's the logic. Imagine if one aluminium ion comes up. To maintain charge neutrality, how many sodium ions will go out? 3 sodium ions will be lost from the crystal lattice. Out of the 3, 1 sodium ion's position will be taken by aluminium. Aluminium ion has to be there somewhere to occupy the space. So one aluminium ion will take the position of one sodium ion. That means will produce 2 cation vacancy. So this logic will be used for further solving of numericals. So if you check, this is a numerical that we have. NaCl is doped with 10.3 mole percentage of strontium chloride. What is the concentration of cation vacancy? That's a question. Then how you are supposed to solve? First, find out number of moles of strontium chloride. It is given as 10 to the power minus 3 mole percentage. Whenever you want to convert any number from percentage to number, you have to divide by 100. That means it is 10 to the power minus 5 mole. If that is what is the case, then what is the number of SrCl2 or number of Sr2 plus ions? Can I say number of Sr2 plus ions will be number of SrCl2 ion units, because of the relation of 1:1. If somebody asks chloride, chloride will be double of this, because one strontium chloride produces one strontium ion and produces 2 chloride ions. So whatever is the number of strontium chloride, same is the number of strontium. Whatever is the number of strontium chloride, double is the number of chloride ions. But this is mole, but you want number, right? Not number of moles, number of ion units. Whenever you want to convert number of moles into correct number, you have to multiply by 6.02 into 10 to the power 23. If you multiply, you will have 6.02 into 10 to the power 18. So number of strontium ions is this. Then we know one strontium ion has a capability of producing how many cation vacancy? 1 cation vacancy. So 6.02 into 10 to the power 18 strontium ions will have ability of producing how many cation vacancy? Answer is same number. So number of cation vacancies is 6.02 into 10 to the power 18 cation vacancies are possible. So number of cation vacancies are 6.02 into 10 to the power 18. Whenever you want to write number in our chemistry, you can very well write down mole inverse, number as a mole inverse. So number of moles of strontium chloride was given. We just converted them from percentage to number. Then we wrote it as number of moles. After number of moles, mole was removed. How to remove a mole? multiply by 6.02 into 10 to the power 23. You got simply a number. This is a number of strontium ion. Whatever is a number of strontium ion, same is a number of cation vacancy. Whatever is a number of strontium ion, same is a number of cation vacancy. So cation vacancy is 6.02 into 10 to the power 18 as a cation vacancy. If you see the next one, which one will produce Schottky defect if AgCl crystal, one of them is added? Schottky defect, what do you mean by Schottky defect? Schottky defect means there will be a vacancy created. So they are asking us to find out who can produce vacancy. Answer is only cadmium chloride can produce vacancy. Why? When you add cadmium chloride, you are adding cadmium ions and you are adding chloride ions. Chloride ions are already present, so they are same as a part of your original crystal. But one cadmium ion can displace two silver ions, of which one silver ion's position will be taken by one cadmium ion and other silver ion's position will remain vacant and will produce a cation vacancy. So who can produce a cation vacancy? Answer is cadmium 2+. That means it can produce Schottky defect. NaCl cannot produce Schottky defect because every Na+ can displace one Ag+. Na+ can displace Ag+. So in place of Ag+, there will be Na+. So no vacancy will be created. Coming to the next one, if aluminium 3+ replaces Na+ at the H center of NaCl, then calculate the vacancy in 1 mole of NaCl. First, 1 mole of NaCl will have 1 mole of Na+ ions. 1 mole of Na+ ions. Next, 1 aluminium ions. 1 mole of Na+ ions means 6.02 into 10 to the power 23 Na+ ions. Then we are aware 1 aluminium ions can displace 3 Na+ ions, and 3 Na+ ions can produce 2 cation vacancies. But we are having 6.02 into 10 to the power 23 Na+ ions. So how many cation vacancies will be produced? Cross multiply this part, you will get number of cation vacancies. So what is the number of cation vacancies? Number of cation vacancies will be 2 into 6.02 into 10 to the power 23 divided by 3. This many cation vacancies will be produced. Now, but you have to go back and see the question. Al3+ replaces Na+ only at the H center. We are aware in NaCl, Na+ occupies edge center, 12 edge center, and will occupy one body center. They are saying only edge centers are replaced, not the body center. That means you are knowing edge centers are responsible for 3 Na+, and one body center is responsible for 1 Na+. So out of 4 Na+, only edge centers are replaced. That means 3 Na+ is replaced. That means only 3/4 Na+ are replaced. I repeat, they have said only edge centers are replaced. You should know edge center contributes only 3/4 because body center contributes 1/4. So only edge centers are replaced. So actual number of cation vacancies will be only edge centers, and edge centers contributes how much? 3/4. So 3/4 of this number will be the answer. Because the question, the way they have said, is quite different. So if you cancel, the answer is 3.01 into 10 to the power 23. Those who have not understood, remember 1 Na+ has 1 mole of Na+ has this much ions. 3 Na+ ions produces 2 cation vacancies. This many Na+ ions will have this many cation vacancies. In this case, we have calculated all the Na+ ions. That means in this case, we considered all Na plus ions are getting replaced. All Na plus ions getting replaced. But if you check the question, they are not saying all the Na plus ions are getting replaced. They are saying only H centers are getting replaced. How many H centers are there? Or out of all Na plus, H centers contribute only 3/4. Then who is contributing remaining 1/4? Answer is body center. So actually only H centers have been replaced. That means only 3/4 number of actual number has been replaced. So 3/4 of this answer will be the correct answer. So this was this numerical, quite different. Write numerical all together, analyze it again, and you will be able to get the answer. Numerical. Non-stoichiometry defect, metal deficiency defect. Base numerical. Like find percentage of ferrous ions in Fe.93O. Now how come this type of formula exists? Reason we have learnt it in the theory too, that it is made up of ferrous as well as ferric. So in this case oxygen is 1. So because oxygen is 1, we took it as 100. If you took oxygen as 100, oxide as 100, this pictorial diagram tells you that there is oxide ions, then there are ferrous ions, and there are few ferric ions also. Because ferrous ferric both exist, therefore it doesn't follow a proper stoichiometry. In this case, let Fe ions, that is ferrous as well as ferric, both be 93. Both ferrous and ferric ions, that is Fe ions, are 93. Let the ferrous ions be X, then ferric ions will be 93 minus X, because total is 93. Then we know to maintain charge neutrality, total positive charge exists on ferrous and positive charge exists on ferric, while negative charge exists on oxide. All the positive charge, all the negative charge, total should be 0. So X ferrous ions, 93 minus X ferric ions are responsible for positive charge, and 100 oxide ions are responsible for negative charge, is equal to 0. So X ferrous ions, and each ferrous ions has a charge of 2, therefore multiplied by 2. Each ferric ions have a charge of 3, therefore multiplied by 3. Each oxide ion has a charge of -2, all added together is 0. So if you solve, X value will be 79. Therefore percentage of ferrous ions will be, ferrous ions are 79 out of 93 multiplied by 100. Definitely algebraically the answer will be more than 79. If you use a calculator, answer comes out to be 85%. This is how you are supposed to do the numerical. There is another example for us of the similar type, metal deficiency defect. How come you have Fe of this formula? Because there is ferrous as well as, there is nickel with 2 plus and nickel with 3 plus. What you will do first thing? Let the number of oxide ions be how much? Yes, correct, 100. Number of nickel ions be how much? It will be 98. If this is 100, this has to be 98. They are asking us for a fraction. So let the number of nickel ions be how much? X. Number of nickel ions be, then will be how much? 98 minus X. Then we know total positive charge plus total negative charge will be how much? Will be 0. What is the total positive charge? Positive charge is with X nickel ions and 98 minus X nickel with 3 plus ions. This is a positive charge, and negative charge is with 100 oxide ions. All should be 0. So each nickel ion has a charge of 2. So X nickel ions will have a charge of 2x. Each nickel ion has a charge of 3. So 98 minus X nickel ions will have this much charge. Each oxide ions has a charge of -2, and total will be equal to 0. And if you solve, you will get the value of X, and whatever is the value of X, that will be number of nickel ions. and remaining you can calculate nickel 3 plus ions, that will be by 98 minus x, and from that you will be able to get the fraction and you will be accordingly able to get the percentage 2, how you are supposed to do the numerical. You got this? This is how you are supposed to do the numerical.